Class 9th chapter circles, some extra and good questions. In a circle, there are two chords AB and CD, which are parallel to each other and on opposite sides of center. Length of AB is 10 centimeter, length of CD is 24 centimeter, and the distance between them is given as 17 centimeter. We have to find the radius of the circle. Okay, how to solve this particular question? First of all, I have joined their midpoints. Okay, the midpoint joined through center is perpendicular to the chord. We have already studied this as a theorem. So if the midpoint of the chord is joined with center, then it is 90 degree. So this is a right angled triangle and this is also a right angled triangle. Now, if I assume any one of the distances as x, then other one will be 17 minus x centimeters. Reason, the total distance is given as 17. So in triangle OMA, perpendicular from center also bisects the chord. So this becomes 5, this becomes 5, this becomes 12, this becomes 12. So in triangle OMA, OA square is equals to OM square plus AM square, that is Pythagoras theorem. So if I write OA square, that is R square, is equals to x square plus 5 square. So R square comes out to be x square plus 25. That is number 1. Similarly, in triangle ONC, OC square is equals to ON square plus CN square. OC square is again R square, ON square, that is 17 minus x ka whole square plus 12 ka square. So I can write it as R square is equals to 17 minus x ka whole square plus 144. If I subtract the two equations, 1 minus 2, R square minus R square is 0, x square minus 17 minus x ka whole square, 25 minus 144. So 0 is equals to x square minus a minus b ka whole square. So 17 ka square, that is 289, plus ka x square minus ka 2ab. 25 minus 144 is minus ka 119. So 0 is equals to x square minus 289 minus x square plus 34x minus 119. X square and x square gets cancelled. 34x, I bring it on this side, so minus 34x. These two can be added. 89 and 19, that becomes 108, so minus ka 408. So minus and minus gets cancelled. X is equals to 408 divided by 34. Can be cancelled by 2. So 204 upon 17 can further be cancelled. 17 ones are 17, 17 twos are 34. So we are getting x as 12. Put x in first. So r square is equals to 12 square plus 25. So r square is equals to 144 plus 25. R square is equals to 169. So r is equals to root of 169, and that comes out to be 13 centimeter. We have another similar question, but this time chords PQ and RS are on the same side of the center. They both are parallel chords that has been given in the question. The length of the larger chord is 16, so perpendicular from center bisects the chord, hence becomes 8 and 8. Similarly, the length of the smaller chord is 12, so perpendicular is coming, so 6 and 6. Perpendicular from center bisects the chord. The radius is given as 10, so I have drawn this one, that is 10. I have drawn this one, that is also 10. We have to find the distance between the chords. That means we have to find x. I have assumed this one as y. This is point O, this is point M, and this is point N. So the solution is in the similar manner in triangle OMQ. If I apply the Pythagoras theorem, then OQ square is equals to OM square plus MQ square. So 10 ka square, that is 100. OM, that is y. So y square plus MQ is 8. The square is 64. Fine. So y square comes on this side. 100 goes on that side. Minus 36. Cancelled. y is coming as 6 centimeter. Number 1. Similarly, in triangle ONS. In triangle ONS. So OS square is equals to ON square plus NS square. OS is 10, so 10 ka square 100. ON is x plus y ka whole square plus NS is 6, so square comes out to be 36. Now we have got the value of y, that is 6. So 100 minus 36 is equals to x plus 6 ka whole square. 64 is equals to x plus 6 ka whole square. Let us take square root both the sides. So 8 is equals to x plus 6. So x is coming as 2 centimeter. So what is the distance between the centers of between the two parallel chords? The distance between two parallel chords is x, and x is coming as 2 centimeter. So distance between the chords is 2 centimeter. This is the diagram. Look here. There are two circles, smaller and bigger, and they intersect each other at C and B. ACD is a straight line. We have been given that this angle is 130 degree, and we have to find the value of x. The question in first look seems quite typical, but let us see how it can be solved. I am joining CB. I am marking this angle as y, this angle as z, and this entire angle as let's say m. So first of all, in the smaller circle, y is equals to half of 130 degrees. That comes out to be 65. Why this y is half of 130? Angle subtended by an arc at center is twice the angle subtended by it at remaining part of circle. तो सेंटर पे एंगल कितना बनाया था AB ने 130, तो AB सर्कल पर एंगल कितना बनाएगा 130 का हाफ, क्योंकि सेंटर वाला एंगल डबल होता है. So y is coming as half of 130, that is 65. Also y plus z is equals to 180, being the linear pair. So z is 180 minus 65. That comes out to be 115 degrees. Also, again, m is twice of z. Same thing, angle subtended by an arc at center is twice the angle subtended by it at remaining part of circle. एक मेजर आर्क ने सेंटर पे एंगल बनाया m, और इसी ने सर्कल पे एंगल बनाया था z. So m is coming as twice of z. So twice of 115, it comes out to be 230 degrees. Then m and x, they are forming the angles at the center of the circle. So x plus m has to be 360 degrees because they are forming the entire circle. So x is equals to 360 minus m. M की value 230. So x is coming as 130 degrees. Same as that of angle given. Exercise 9.5 from new book, exercise 10.5 from old book. We have been given that AC is the common hypotenuse of two right angle triangles ABD and ADC. Prove that angle CAD is equals to angle CBD. What we have to prove? That angle CAD is equals to angle CBD. BD अभी मैंने join नहीं किया था. I'll be joining it soon. Now, how to prove this question? It is simple, but based on a theorem, that is 9.10. What was the theorem? If a line subtends equal angles on the 2 points on the same side of it, अगर कोई लाइन अपने एक ही तरफ दो पॉइंट्स पर इक्वल एंगल बनाए तो ये चारों पॉइंट्स कॉन्साइक्लिक होते हैं. सो B and D are on same side of AC such that angle ABC is equals to angle ADC, and this is given equals to 90 degree. So using theorem 9.10, I can say that these 4 points are concyclic. That means they will lie on a circle. It cannot be drawn a perfect circle because the diagram is just hypothetical, but these will be concyclic points. So using theorem 9.10, we can say that AB, DC are concyclic. Now I am joining BD. If I look carefully about these two angles, if I extend the arms of these two angles, I am landing at CD. And if I'm extending the arms of these two angles, again, I'm landing at CD. So angle CAD is equals to angle CBD by the property angles of same segment. There can be one more case for this question. What is that one more case? What if B and D are on opposite side of the AC? It's not necessary that B and D will both be lying on the same side. What if the B and D lies on opposite side of AC? Because the question never mentions that they are on the same side of AC. So one is this one and one is, let's say, this one, ADC. They both are right angled triangles. Now, if I look at this entire figure, the sum of the opposite angles is 180 degrees, 90 and 90. So if the sum of opposite angles of a quadrilateral are 180, then it is a cyclic quadrilateral. That means in this case also, the points A, B, C, D will be concyclic. Fine. So in that case, if I join this one and I talk about these 2 points, these 2 angles. So A, B, C, D is again concyclic. Reason? Cyclic quadrilateral. The sum of the opposite angles of cyclic quadrilateral is 180. And since this sum of the opposite angles is 180, it has to be cyclic quadrilateral. So again, angle CAD is equals to angle CBD. CAD, if I extend both of them, I'm landing at CD. CBD, if I'm extending both of them, I'm landing at the same place, CD. Angles of same segment. So whether B and D lies on same side of AC, whether B and D lies on opposite side of AC, the theorem or question holds true in both the cases. CAD and CBD are equal by the same property, angles of same segment. The last question of the exercise, that is 13th question, I guess. It says that prove that a cyclic parallelogram is a rectangle. So we have been given that ABCD. मैंने बनाया तो rectangle जैसा ही है, लेकिन question ये कह रहा है कि ये एक parallelogram है और हमें prove करना है कि ये एक rectangle है. बहुत ही आसान सा proof है. I have just marked 2 angles, 1 and 2. So angle 1 is equals to angle 2. Reason? Opposite angles of parallelogram. But angle 1 plus angle 2 has to be 180 degree. Reason? ABCD is a cyclic quadrilateral. So if I replace angle 1 by angle 2, plus angle 2 is 180. That means twice of angle 2 is 180. That means angle 2 is equals to 90 degrees. So as soon as this angle 2 becomes 90 degree, this becomes also 90 degree. Same thing is applicable for these 2 angles. So these 2 will also become 90 degree. And if the angles of a parallelogram becomes 90, then it becomes a rectangle. So all angles of parallelogram ABCD are 90. Hence, it is a rectangle.